Hi there. We're going to look at variation, and I'm going to try to, there's like 3 or 4 different kinds of variation problems in this lesson, and there's regular ones and then there's applications. So I'm going to give a nice sampling of all those types. You can fast forward to what you need if that would be more helpful to you. Ultimately, there's 3 types of variation that we're going to deal with. There's direct variation. Direct variation means like something varies directly with something else. A common example of that might be like, if you think of the formula distance equals the rate times the time, and think of the r as your constant. So the distance that you travel varies directly with the time that you have traveled, as long as your speed or your rate would stay constant. So that would be like my k. Now there's like examples for inverse and joint, and we'll hit those as we go along here. Let's try, just jump in. I'm going to start with a direct variation example. Direct variation is probably the most common scenario, and you'll see that they word it differently. It might say if y is directly proportional, like this one says, or it might just say if y varies directly. It might just say y is proportional. All of those are direct variation. The key thing to notice about on direct variation is that in this format, whatever the constant of variation is, that's the k, the constant of variation gets multiplied by your variable. Now, we can tweak this format, but the key is that there's multiplication going on between those two. Let's try one. This first example says if y is directly proportional to x squared. All right, so really I'm going to tweak that direct variation, and it's going to read y is directly proportional to x squared. So I have to square that x. And then what they do is they'll give you a scenario where they give you everything except for that constant, that k value. So you fill in what you know. So it says y is 313 when x is 19. And your goal here is then to figure out what is the constant of variation for this particular problem. So I've done all the math already on my calculator to kind of hurry along our video, but ultimately I would just need to divide both sides by 19 squared. And I get k to be 0.867. Now you need to leave a lot of variables on that constant, and in fact I would leave that number sitting on your calculator ready to use. If you round off too early, at the end you might be off by a hair and then it gets counted wrong. So it says for the final answer to be rounded to the nearest hundredth, but I don't want to get too anxious at rounding early. So I went ahead and put 0.867 there, but I left it in my calculator. And that's going to be the case throughout. All right, so now I figured out the k value for this particular situation. So I am going to rewrite my formula now. I'm going to write a better formula. It's now y equals 0.867 x squared. And that's the relationship we have in this scenario. I'm going to use that then in the second part, because in the second part they give you something to search for. So the second part says find y if x is 10. So I'm looking for y, but I know that x is 10. So all I have to do then is multiply those together. Well, 10 squared is 100, and 100 times 0.867 would be 86, and it actually did round off to like 0.70 is what that rounded off to. All right, there we go. That's the scenario kind of every time. We're going to work with some given information to find k. We're going to rewrite our formula with that k value in it, and then use that new formula to solve what they're asking for. Those are kind of your 3 steps every time. Now this second one is still direct variation, but it's one of the applications. And sometimes those are a little bit trickier to understand what they're talking about or where values go, so I'll help you with that. It says the distance that a free falling object falls is directly proportional to the square of the time that it falls. So distance varies directly with the square of the time. So distance varies directly with the square of the time. That's what that means. Let's go with if an object fell 43 feet, that's a distance. I'm looking for the K value. Oh, and it fell in 3 seconds, so that will be 3 squared right there. Well, that's just a 9, and so I would divide by 9, and I get a K value that is 4.7 repeating. So I'll just write a bunch of 7s there, again, not rounding too early. Once you have that K, then you rewrite your nice formula with that K value in it. And then they give us a second scenario where we're searching for something. It says, if an object fell 43 feet in 3 seconds, that's what I did, how far will it have fallen by the end of 9 seconds? So I'm going to put 9 in for t and find my distance. And again, I just typed that in my calculator quickly, so I ended up with the distance being 387, and it says to round to the nearest foot, so I just rounded it right to there. All right, let's keep going. Now I'm going to try an inverse variation problem. This says if y is inversely proportional to the square root of x. And then they give you some more information. All right, so looking at this inverse situation, now your k is always going to be divided by your variable. And again, I'm going to take this general format and then tweak it to the information they gave me. Y is inversely proportional to the square root of x. That right there tells me how to set it up. Y is inversely proportional, which means you have to divide by the square root, not the square, but the square root of x. So this will be my formula, and then they're going to come back and give me information so that I can figure out the k. Y is negative 84 when x is 121. Right, that's enough information then. And they're actually pretty nice with their numbers. Oops, that's a pretty ugly k there. And it's the square root of 121. They do tend to give you perfect squares there. That works out beautifully. So it's a k over 11. So I'd multiply both sides by 11. And I found k to equal, oops, where's my numbers? K equals negative 924. Now I'm going to rewrite this formula with that k value in there. So y is equal to negative 924 divided by the square root of x. And this is the formula then that I can use to solve for what's coming. They gave me this. Now the question is, find y if x is 14,641. My goodness. Okay, here we go. Y equals negative 924 over the square root of 14641. Okay, I said they were nice. I know that's crazy, but in all honesty, that's a perfect square root. So it actually comes out very nice. It's the square root of that 14,641 is 121. So then all you're going to do is type that in your calculator and get a decimal value for that. They ask us to round to the nearest hundredth. All right, now let's try one that's inverse, but it's one of these word problems. The gravitational force between an object and the earth, the gravitational force, F, between an object and the earth, so that gravity force between something and earth. Okay, it's inversely proportional to the square of the distance from the object to the center of the earth. Okay, these just tend to get wordy, and so you just kind of got to get and do enough of them that it starts to make sense. Okay, so here's the earth. They tell us that the radius of the earth is 4,000. Got that. And I'm going to have, it talks about an astronaut here standing on the surface of the earth, so my astronaut is up here. All right, so let's see what we've got. The gravitational force, F, is inversely proportional, so it's going to be K over, It's inversely proportional to the square of the distance. So I'm going to call that d squared. And that distance is to the center of the Earth. That's why they told us the radius of the Earth over there. If an astronaut weighs 207 pounds, that's your gravitational force. That's your weight. It's based on the gravity. All right, so F is going to be 207. We don't know the K yet. Now, if you think about it, the astronaut is standing on the surface of the Earth. So what is the distance to the center of the Earth? It's that 4,000. Now, you can type that in your calculator, or it just kind of depends on how savvy you are with your calculator. Maybe you need to write it out and then multiply, but you're going to end up multiplying by that huge number there over to the other side. All right, so I get for K, that's my K value for this scenario. Then what I'm going to do is redo my formula. This formula right here gets rewritten with the K value in it. Change colors on us here. So my new formula that I'm going to use for the rest of the problem is this right here. And I use that to answer the next question. It says, what will the astronaut weigh 500 miles above Earth? Okay, so now they're in some sort of a spaceship, and we are figuring out what they would weigh while they're up in space. So since I'm wanting to know what they weigh, that's the force. The distance, now if you think of your little astronaut over here, he was 4,000 feet from miles from the center of the Earth, but now he's 500 miles even higher, so that would be 4,500 squared. Don't forget to square. That's the most common thing, is we write that and then we forget to do it, so make sure you do that. And then you would just type that value in your calculator, and it would be 163.56 pounds. All right, we have one more. Well, actually, hang on. We are not going to do joint yet. Sometimes you have more than one type of variation going on with your situation, and then that gets a little bit confusing. So let's try one of these. It says Z varies directly, so it starts off fine, varies directly and inversely. So I have more variables going on here. This right here, I'm only going to have one K value. One of these is going to get multiplied by K. One's going to get divided. So Z is going to be directly related to the square root of X, so that means I have to multiply it, but inversely as Y, so I'm going to divide by the Y. That's how we want to set it up. So then we take the info they give us, and we go figure out what K will have to be. So here's the three things that they give us. We know these three scenarios. Once we find the K, we'll use the rest of that. So Z is 116. When X is 36 and Y is 3. Okay, so the square root of 36 is just 6. And there's a couple ways you can do this. Again, it's kind of your comfort level and your preference. You could multiply both sides by 3 and then come back and divide by the 6. Or this is really just a fraction. You could reduce these two. 3 goes into both of them, so this would go away, and that would turn into a 2. Whichever way, 116 equals 2 times the K, so I'd have to divide by the 2. So I have K equaling 58 on this problem. So that's the constant of variation for this particular scenario. Now let's use that and let's rewrite our formula with that in it. So now it's a Z equals, and instead of K, I write 58 square root of X all over Y. And we use our new formula then to finish it out. It says find z if x is 49 and y is 9. Find z, x is 49 and y is 9. So you're going to have 58, and I would just type it in my calculator, 58 times 7 divided by 9. All right, and on this problem, got to find it, sorry. Z ends up being 45.11. All right, so that combination of direct and inverse, let's try it with a word problem here. It says the resistance of a wire varies directly as its length and inversely as the square of its diameter. So I'm going to use the R for the resistance. Varies directly as its length, so K is going to have to get multiplied by the length. I usually use like a cursive L. And inversely, so it's going to have to get divided by the square of its diameter. There's my formula. Then let's fill in numbers so we can figure out the constant for this problem. So the resistance of a wire 3,000 feet long. Okay, that's the K. I'm sorry, that's the L. With a diameter of 0.29 inches, so it's going to be 0.29 squared, is 3,227 ohms. I slow read these, so that's the resistance. The resistance of a wire that's that long and has that diameter is, and resistance is measured in ohms. So my goal here then is to solve for K. I would find that 0.29 squared and multiply both sides by that. And when I have that, I'm at 271.3907 equals that K times that 3,000. I always like to put my variables at the end. That's why I switch the order. That doesn't really matter whether the K comes first or the 3,000. And K is, again, leaving lots of decimals here. You can't round too early. Plus, just leave it sitting in your calculator to use. Now, my new formula with my K value is now R equals 0.09046 L over D squared. Now, let's use our new formula to solve for what they want us to solve for. It says, what is the resistance, so we'll be looking for R, of 600 feet of the same type. Okay, so hang on. R equals 0.09046. And it's 600 feet, that's the length, of the same type of wire with a diameter of 0.46 inches. So different wires have different resistances. So this particular wire, I guess, has different gauges. And so all we would do then is type that number that's sitting in your calculator already, just take it times 600 and divide it by 0.46. Our new resistance is 256.51 ohms. All right, last type is our joint variation, and joint just has more stuff going on with it. You can see here that there's now a z is equal to, we're still multiplying, but your constant gets multiplied by two variables in this situation. It gets multiplied by the x and the y. And of course, I can continue to tweak this, and sometimes things are squared or cubed or square rooted, and I tweak it accordingly. Let's see what we've got. It says z is jointly proportional. So if it uses that word joint, boom, you know you're in joint variation. Jointly proportional, so that tells me what I'm going to multiply k by, to x squared and y cubed. There's my formula. Now they're going to give you the information to figure out k for this problem. If z is 431, when x is 2, and y is 3. All right, let's see if we can figure out what we'd have here. 431 is equal to K times, that would be 4 times 27, so that's a 108. Divide both sides by 108. And I have K is equal to 3.9907, leaving lots of decimals. Don't want to round till the very end, and leaving that just sitting in my calculator ready to use. Here's my new formula. Z equals 3.9907 times x squared y cubed. Now let's use that formula to answer their question. Right here it says, find Z when x is 3 and y is 7. Find Z when x is 3, so that's going to be 3 squared, and y is 7, so that's 7 cubed. And then I would just type that in my calculator. A 7 cubed would be like this in your calculator. You do 7, and then you have that caret button, cubed. 7 cubed. And really, you could enter this left to right in your calculator. You already have the 3.99 number sitting there. Just hit times, and you have an x squared button, but you could just do 3 squared in your head also. That's 9. And then your 7 to the third. And all together, then I have 12,319.42. All right, now let's do this joint variation with a word problem. Okay, so the lifting force, F, exerted on an airplane wing varies jointly as the area of the wing's surface and the square of the plane's velocity. Okay, so the lifting force, that's what lifts the plane up in the air, is going to depend upon the size of that wing and how fast the plane goes. Okay, that all makes sense. This is nice, like engineering kind of formulas we're dealing with here. The force varies jointly, so I have to multiply the K jointly as the area and the square of the velocity. That's what that would look like. All right, let's plug in some numbers and see if we can find K. The lift of a wing with an area of 190, okay, so 190 is going in for area, is 9,500 pounds. That's the lift force when the plane is going 220 miles an hour. Notice how they give you these numbers, and it's not always in the order you'd like it, so you just kind of fill in as you get it, and the only thing missing is K. So I'm going to multiply that stuff together. And then come back and divide. I got, for a K value, again, leaving lots of decimals here. So I'm going to rewrite my formula. Now it's an F equals 0.001033 times the area times the speed or the velocity squared. All right, let's see what they're wanting now. All right, to find the lifting force, that's F, find the lifting force on the wing if the plane slows down to 190 miles an hour. And it says leave the variation constant in fraction form or round to at least 5 decimal places. That's what I was saying. Don't round off. Round off your final answer to the nearest pound. All right, so let's fill in what we can. I'm looking for the force. And it said it slowed down to 190 miles an hour. That's the speed over here. But it took me a minute to say, well, what's the area of the wing? They didn't tell me. Oh, it's still the same plane. Okay, so the area stays the same. It's still 190, which is a coincidence. These are both 190s. That wouldn't be typical. All right, now you just type that in to your calculator, left to right, and you should get a force of 7,086 pounds. That's rounded to the nearest pound. All right, I have one more for us. Okay, I kind of like this one because it makes sense in my head, I guess. I'm no engineer, but it still makes sense to me. So it says the safe load, L, of a wooden beam supported at both ends varies jointly. Okay, so this is the load. This is how much this beam can hold. I almost think of it like if it's a bench or something like this. Here's my bench. I'll draw a nice bench. And it's supported on the ends here. Okay, so it's only supported on the ends. And so how much that bench or that beam can support varies based on the width, how wide is the bench, and the depth, which is like the piece of wood here, how thick is that wood. So it varies jointly with those. So that makes sense to me because the wider it is or the thicker it is, the stronger and the more this is going to be able to hold. So I'm going to multiply it jointly as the width and the square of the depth. But think about the rest of this. And, okay, because I'm not done, square the depth, and inversely as the length. Doesn't that sort of make sense? Like the longer this would get, it would start to bow in the middle, and so it would get a little bit weaker the longer it is. So that's why we divide by the length. All right, so there's our formula. Now let's see what K is for this particular piece of board. Here we go. Okay, here we go. A wooden beam is 5 inches wide, 8 inches deep, 19 feet long. And it holds up 3,551 pounds. All right, that's all the info we need to fill in so that we can go figure out K. So the load is the 3,551. I don't know the K for this for this particular beam. The width is 5. It's 8 inches deep, and it's 19 feet long. So I'm going to take K, and it's going to be 5 times 64. Oh, I lost my piece of paper. Here it is. Okay. I get 320 for all of that. Oh, what I went ahead and did is I went ahead and multiplied both sides by 19 on this. So maybe I should, can I erase this? So then it became 67469. And then the 320 is just the 5 times the 8 squared. Now I'm going to divide both sides by 320 to see what K is. And I get 210.8406. I'm going to rewrite my formula with that K value. Do you see that kind of this process is the same? I've done about 7 of these. The process is the same. You fill in what you can, you find K, you rewrite the formula, and then you use your formula to answer their new question. So going back to this, I got started on rewriting this formula right here with the K value. It just got lengthy with that K value. And it's times the width and times the depth squared. Those are all multiplied, but you have to divide by the length of it. All right, let's use this new formula to see what they want. It says, what load would a beam that's 6 inches wide, 10 inches deep, and 18 feet long of that same material, because this is for this particular board, all right, what load with that information would it support? The width was 6, the depth was 10, and I have to square that, don't forget squaring it, and I have to divide it by the length. And then I just type this in my calculator. I multiply the 210 number times 6 times the 100, that is 10 squared, and then I divide it by 18, and I have a load of 7,028 pounds. All right, that was pretty much one of everything, so hopefully this helps.